Welcome! Today we'll solve a calculus problem involving successive differentiation of the secant function. Let's look at our question. Let's solve this step by step. We'll start by finding the first derivative. The derivative of secant x is secant x times tangent x. So y1 equals secant x tangent x. Now for the second derivative, we need to differentiate y1. Since y1 is a product of two functions, we'll use the product rule. Remember, the product rule states that the derivative of u times v equals u prime times v plus u times v prime. Let's apply the product rule to y1. Here, u is secant x and v is tangent x. We know that the derivative of secant x is secant x tangent x, and the derivative of tangent x is secant squared x. Now let's substitute these derivatives into our equation. We get secant x times secant squared x plus tangent x times secant x tangent x. Let's factor out secant x from both terms. This gives us secant x times the quantity secant squared x plus tangent squared x. Here's where we can use a fundamental trigonometric identity. Remember that tangent squared x plus 1 equals secant squared x. Therefore, tangent squared x equals secant squared x minus 1. Substituting this identity, we get secant x times the quantity secant squared x plus secant squared x minus 1, which simplifies to secant x times 2 secant squared x minus 1. Finally, recall that y equals secant x. Therefore, we can write y2 equals y times 2 y squared minus 1, which was what we wanted to prove. And that's how we find the second derivative of secant x, and show it equals y times 2 y squared minus 1. Thanks for watching.